All right, wonderful students. Today we're going to be going over section 1.2.3, domain and range. Domain and range is one of the topics that it is on chapter 1 test. So we're preparing for that. So start by writing your name, please, your period number, and today's date. Here we go. Problem number 1-55. Listen closely and write down these notes. Determining domain and range. Work with your team to describe in words the domain and range of each graph below. Then state whether or not the graph represents a function. So for these first ones, I'm going to do the first three, and I'm going to ask you and your team to do the next three, and we'll check our work. As I solve these, I want to see if you can figure out the next one as well. Okay? So here we begin. Domain. Domain is defined as the X inputs. X values, which are the inputs. Range is all the Y values, which are the outputs. So I also like to see it this way. Domain is how far left to how far right does the graph go? That's domain. Range, what else could it be, right? From left to right, and then from, not top to bottom, but from bottom to top, least number to greatest number. That's going to be the range. Okay? And there's multiple ways to write it, but let's go ahead and do the first one. This is the most important piece. Can you tell me the farthest left number to the farthest right number? So it looks like the farthest left number is, on the graph, the X values, the farthest left is not -4, right? That's -4. This would be -3. So I'll say -3, 2, and it goes all the way to 3. What about the range? How low to how high? Think about it kind of like a mountain range, where we have some mountains, and we're thinking about how tall are these mountains. Okay, the range goes from -3 to tallest point, -3 to 3 as well. Okay, we're going to do the next one, and then we're going to come back to these questions. Okay, so the next one is domain. How far left does this one go? Look at this one. This one has an arrow. The arrow means it goes on forever. So I want you to say -infinity. And the farthest right it goes, this one goes on forever. So it goes from -infinity to infinity. What's the range? How low to how high? Yeah, if you noticed, we have a new idea possibly for you. There's infinity. Infinity is like to infinity and beyond. Infinity just means it goes all the way left forever. You can write that down. Forever. Forever negative. Deeper and deeper into the negative number. Okay, so that's how we write it down. -infinity to positive infinity. Now range. How low to how high does this graph go? The arrows show that it's going to go on forever in this direction and forever in that direction. So that we're also going to write -infinity to, how high does this go? Yes, the range is also infinity. Okay, our next one. This one, you do have to look at these pretty closely because this one does have a stopping point. How far left does this one go? It looks like the farthest left it goes is -1, -2. So I'll say for the domain, the leftmost number is -2. Does this have an arrow on it? No, it's a dot. So that's not going to go on forever. What's the farthest right that it goes? It goes on to the number 4. So it includes every number between 4 and positive 4. Now what about the range? How low? Again, draw these boxes. It makes things a lot easier for you when you draw the boxes. The lowest point to the highest point. I'll give you a chance to draw that box. What's the lowest point and what's the highest point? Okay, the lowest point is going to be -4. We're looking at the y-axis. The range is the y. So the lowest is going to be -4 right there. 2. How high does this one go? It looks like it goes to a y value right there of +2. So we'll say -4 to 2. Remember, we don't write 2 to -4. We write the least number to the, that's right, always write it from least to greatest. Just a note, remember to write these things from least to greatest. Okay, our next one is we're going to go ahead and continue to practice whether a function is, or a graph describes a function, or if it's not a function. How do we determine if a function is, well, a graph is a function or not a function? So we just learned from the last test that to be a function, every input, which is x, must have exactly one output, which is y, to be a function. So I'm writing that down. To be a function, every input, x, must have exactly one output, y. So the way that we tell this really quickly from a graph is we draw a vertical line. So we draw a vertical line. I'll go ahead and write this down right here as well. VLT. VLT means what? Yeah, VLT is going to be the vertical line test. Let's practice that. The vertical line test. If I draw a vertical line, does it go through more than one point? Check it out. This one goes through more than one point, so it's not a function. It fails the VLT. Okay, it fails the vertical line test. To be a function, every x has to have only one y. Every input has to have exactly one output. Kind of like the vending machines. So this value right here, +1, should have only one y value, not 2. So the vertical line test, it kind of tells us that pretty instantly, whether it's a function or not. It should only go through one dot. Since it goes through 2, it's not a function. Okay, next one. Draw a vertical line. You can also take a ruler or a pencil and see if it goes through one dot. So this one only goes through one dot. So what do I say? Yes, this is a function. And the next one, draw a vertical line. It's okay to go through no dots. Over here it would go through no dots because there's no arrow. But let's just draw a vertical line here and see that it only goes through one dot. So it must be a function. Okay, I'm going to go ahead and let you try the next 3 problems with your group. So I'll ask to pause the video here, and I want you to go ahead and try these next 3. I'll leave these ones for reference. Remember, some of these can be pretty difficult, so let's do our best. All right, let's go ahead and check our work. So for the first one, the domain, left to right. How far left does it go? This one's pretty tricky. You see that arrow? That arrow means it's going on forever. Since it has an arrow pointing in this direction, any left direction is going to go forever, 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 forever. So the domain is going to be negative infinity to, what's the farthest right it goes? It doesn't stop here. It's got an arrow pointing at an angle. So it's going to go on and on and on and on forever. Okay, let's try the next domain. Let's see if we got this one right. How far left does it go? The farthest left it goes is positive 2. And the farthest right that it goes, I hope you got this. This is a good one. The farthest right that it goes is 4. So you say 2 to 4. All right, the next one. The farthest left that this graph goes is, what x value is that? 0. And the farthest right that it goes on forever. So we're going to go ahead and say 0 to infinity. Okay, let's go ahead and check our range values. Range is how low to how high. So the lowest point right here is going to be, the arrows show how low does it go? Forever, forever, forever. How low is that? Yes, it's going to be negative infinity. And what's the highest point that it goes? Draw the box around these graphs and you'll be able to see that the highest point is positive 4. Pretty tough. That's a tough one. I will be honest about that one. That's a very tough one. But here we go. The next one. The range, the lowest to the highest. Draw the box around your graph, around your function. This one's not a function, but let's see how low to how high it goes. From negative 3, the lowest point, to, how high is that one? This number right here, 1, 2. It goes up to 2. Okay, let's check the next one. How low to how high? This one has a stopping point right here. Looks like the number's 1, 2, 3. So 3. And the highest point. This one's tough. Does this one have an arrow going on forever? Is it going up and up and up and up and up and up forever as well? Yes, even though it looks like it's going to stop at some point, this one goes on and on and on and on and on and up and up and up forever. So the highest point in this range would also be infinity. Okay, let's check our next piece. Is it a function? Did he draw the vertical line test? Did it go through one dot? Yes, this is a function. Next question, did you draw the vertical line? Look at this one. This one's crazy. This one goes through 1, 2, and 3 points. Every input has to have how many outputs? Exactly 1 output. So you'd say this one is not a function. All right, and the next one, the last one here, do we draw a vertical line? Does it go through exactly 1 point? Yes. So this is a function. Okay, we are going to add one more thing to this page. I do need you to know that there is another way to write domain and range. Domain and range can be written in like this. It can be written like this with a bracket. And it can also be written in another form. But for this first part, I do want to show you the brackets. So brackets means, does it stop at that number? So you just put -3, comma, 3. It stops at that number, so you put a closed bracket. Infinity is a little bit different. Infinity is an open bracket, or it's got a parentheses, because infinity never stops. So you'd write this as negative infinity, comma, infinity. What about this one? Right? It stops at -2, and it goes all the way to 4. Okay? Next one. This one, another way to write this is going to be parentheses, negative infinity, comma, infinity, otherwise known as all real numbers. If it's all the way from negative infinity to positive infinity, that includes every single number. All right, next one. 2, comma, 4, because it goes from 2 to 4 with a closed bracket. And here's the last one that's really tricky, but you'd say 0 with a closed bracket. And infinity, what do we use for infinity? You have to see the difference in that. Infinity never stops, so it's got an open bracket. You see how weird that is? But that is one of the 3 notations that we will learn. Okay, let's do the range. I'll start here on the bottom. The range. How do we write range? So let's write it in this notation as well. Negative infinity with the parentheses, 2, 4 with a bracket. What about the next one? Bracket, -3, comma, 2, closed bracket. Last one, 3, 2, infinity. What do we do with infinity? Infinity doesn't have an end, so we have to have an parentheses, closed parentheses, like this. Okay, now I would like for you to do the next pages. Working with your team, complete problem 53, which is down here, 54. 56 and 57. If you get finished earlier, you can finish problem 58, which is the team challenge. Okay.